Hey, so we're checking out your project turn-in for assignment 8, squash and stretch. And, really good job on your idea here. It's nice and creative. I like what you did with the squash and stretch concepts here. I'm just going to give you a couple of pointers to improve your squash and stretch further. And it's just one concept that has kind of been left out that's really important and key for squash and stretch. And that is the idea that an object, even when stretched out or squashed down, will retain the same amount of volume, okay? So basically, it helps to think of this kind of like a water balloon, alright? So if you have a little water balloon filled with water, it's nice and round, just sitting there. Now when you apply pressure to the water balloon, two things happen, and I'll demonstrate this with an amazing sphere, so you can just kind of have a visual to go along with what I'm talking about here. Alright, so I've got this sphere here. This is my water balloon. Use your imagination. So a couple things happen when I squish this water balloon down, and the first thing that's going to happen is that it's gonna get smaller in the y direction as I'm applying force to it from above. However, if I just leave it at that and say, okay, now it's squished, I squashed it, in real life, the only way that this could be possible would be if somehow the water escaped from the water balloon as I was pushing it down, okay? So basically, anytime that you put that pressure on there, the water that's in the balloon is still going to stay in there. It's just going to be displaced, okay? So it's going to have to go in a different direction. It's going to have to go somewhere, but it can't go where it previously was, which is, up here. So as soon as we squish it down, that water is going to be pushed outwards in other directions, alright? So we scaled it down in Y, but to make it truly realistic, we're going to have to also balloon this out in scale X and scale Z. So, I can do something like 1.3 in these over here. Okay, so now, as I'm pushing down, the water is displacing all around, okay? So it's just flowing outwards, alright? So, I'm pretty sure you can grasp that whole idea, or you can grab a water balloon if you want to have some fun with it and try it yourself and just kind of see how it works. So, let's apply that to what's happening here with your animation, okay? So we start out with this really, really massive object here. This looks like, if you just picture this being full of water or something, we've got a whole bunch of water that could potentially fit in this thing, right? And then as we squish it in, you can see if that thing was filled with water, it must have disappeared somewhere, because this is a much smaller object now than what we started with. This could hold a whole bunch, and this object here is really tiny, okay? And then it just comes back to a nice, pretty sphere. But again, the sphere that we get here looks like it could only hold a little bit of water, whereas this that we started with could put like a whole big lake in there. So let's go ahead and fix this up a little bit. So in this case, we're stretching it and squashing it in scale X, so it's going to be our other two, scale Y and scale Z, that are going to be affected. So, anytime scale X is getting bigger, okay, so it started at 1, and now at this point it's at 7.059, that means scale Y and scale Z are going to get smaller, alright, to accommodate for that. So let's make those really tiny. This thing thing is stretched out really, really far, okay? It's way stretched out. And we'll just go ahead and grab those two, and we'll key selected, all right? And just so you know, the way that I did that was just to click and drag right here, and to grab both of those. Then just right click and hold and hit key selected, okay? Now I'm gonna slide my time slider over. Okay, so you know this is all going fine, really. You know, you can see it squishing down as the walls are coming closer. And then right about here is where, you know, we run into trouble again, where it's squashed really super tiny, but it hasn't ballooned outwards in the other two directions, okay? So here again, at frame 12, we can adjust this, so we can say, all right, our scale X is smaller than 1 at this point, so our scale Y and our scale Z should be larger, all right? So we'll make those bigger. I'll put, okay, well, 5 is a little crazy. Let's try 2. And you know, you can just, you can adjust these the way you like them, and just test your animation and see if it looks right, or if it looks not quite right, you know, and just readjust. Alright, so we'll key those as well. So alright, we're starting out with this big long thin thing. It's coming in. Doing that, squishing, and then it's returning to normal size. So one problem that you might notice is that it seems like it's gaining a lot of volume right about here. Okay, so we probably don't want it to be quite so huge at this point, only wanting it to squish, you know, kind of when that wall starts closing in on it. So right about maybe here, I'd say put in, let's put in 1s and see what kind of shape we get. Alright, so you know this is not quite right because the walls aren't touching it anymore, so maybe let's try right about here at 10. We'll try 1s, 1, 1, 1. This is a little closer. So, you know, kind of in between these two frames is where the ball would be about regular size before it starts getting squished, okay? So we really kind of want to identify that point of where it would be normal size, alright? So what I'm going to do is I'm going to go ahead and start right here with 1s, okay, on frame 9, and then I'll just slowly stretch this out just a little bit. Let's try 1.2. Maybe? Okay, so I'll do that. And since it is stretched out a bit, then I'm also going to have to thin it down in scale Y and scale Z just a little. Let's try 0.8 maybe. Okay, and I'm going to go ahead and grab all 3 of those and key those. So now I've also established a point where the ball is pretty close to normal size before I start that dramatic squishing process. Alright, so we've got it way stretched out, we've got it coming back to normal, we've got it squishing and going back to a nice round ball. Okay, so you know that's looking a little bit more natural now. It's not as obvious that you are, you know, gaining or losing any volume. So it's appearing like this ball is staying with the same volume and the same mass the entire time, rather than growing and shrinking. So that's it for this demonstration today. Let me know if you have any questions about anything that we went over. And thanks for watching, and happy animating!